So, you want to have all the querying advantages of denormalization with none of the risks? Well, you can have it both ways. You can use a technique called materialized views to preserve your normalized form in the database, but also have a denormalized form as well. Let's review what we know about views. A view can be created from any query, and thus, if you look at a view, you might assume that the data is denormalized because maybe the view has joined multiple tables. But every single time you use the view, that denormalization is really a myth. It recreates the view every time. The view is not persistent. Its data is always being regenerated. And so there's not really much difference between using a view and running queries in terms of efficiency. A materialized view, though, is persistent, and a materialized view stores the data in that form in the database. So it never has to be regenerated. How does a materialized view work? Well, you're not going to see them in MySQL, but Oracle has them, for example. And so if we look at the table on the right-hand side, and let's say we change 2 rows of that table in red, then the Oracle system immediately puts them into a material view log. It's kind of like an audit table. It's keeping track of all the changes that are being made to the tables. Then, periodically, and you can control this, the material view log is going to update the data in the materialized view, or M view. Now, this is important because the M view is no longer under control of any user. The M view is only changed through this materialized view process. So no one else can change that data, and it's very controlled. This way, the system keeps track of every single change and manages those changes into the materialized view. So, a materialized view is a replica of a master table at a point in time, and they're updated from one or more of these masters, and it's called a refresh, when the materialized view log refreshes the materialized view. Here's an example of a materialized view in Oracle. It's created with the create materialized view statement, and you'll notice that it's creating a view based on 2 different tables, TPM project version and TPM project. And so it builds the view, but then there are certain keywords you can use to drive the behavior of the materialized view. And you can see some of the options on the right-hand side. There's options for the build clause, options for the refresh types, and when the refresh is triggered. They could be triggered, for example, on commit. As soon as you actually save data in a table, you can force the materialized views to be refreshed, or they can be refreshed on demand, either by a manual request to update the materialized view or a scheduled task. Perhaps you want your materialized views to be updated every morning at midnight. And so the data might be 1 day old, but it's reasonably current. So you can control exactly how you manage materialized views, and that's a good thing, because now your customers can use the materialized view, and basically they're using a denormalized table at this point, where the data is stored as a table. Even though it's called a materialized view, it's persistent, and therefore it's very fast. So the materialized views are important for performance enhancement and query optimization, because you'll be querying data in a very denormalized fashion. But these materialized views are only part of the story, and if you can actually go into much bigger systems of denormalizations, something called data warehousing. Views and data warehouses are similar in some respects because they have read-only extracts from the database, and they allow you to group them by subject. But a data warehouse is different. The data warehouses exist as persistent storage. They're not materialized on demand. They are always there. They can have multidimensional views with aggregation. They can be indexed. They can have large amounts of data, And you can use a technique called ETL, extract, transform, and load, which is a very complex process to build a data warehouse. And when you have a data warehouse, what you have is one structure for querying and analysis. That's the data warehouse. But you have the underlying normalized tables for data storage and data integrity. And so you're getting the best of both worlds. If you enjoy working with data in this way, you might look into data warehousing, which is a whole discipline unto itself. Data warehouses collect data from many different sources. It extracts, transforms, and loads them into operational data stores, which can then move into data warehouses, which can then move to data marts. Each of these have their own special usage in business data analytics. And there are BI tools you can use, business intelligence tools like OLAP cubes, reports, and dashboards. So this gives you a little flavor of what you can do with data once you create a second copy of it.